Hi, and welcome back. Last time we talked about factorials, and today we're going to be talking about combinations. And in the next part of this trick, we're going to be talking about how you can find them in the Pascal Triangle. To understand what combinations are, we're going to take a look at a problem. And it's how many ways are there to select 3 people from a group of 8 people if order doesn't matter. As you see, I have put 8 stick figures on the screen. So let's take a look on how we would attempt this. Let's say we have 3 spots. We have 8 people that we can pick to put in this first spot. So there's just going to be an 8. Because there's 8 ways to pick who is first. Then, let's say we picked Anna. Then, there's 7 people of who we can pick second, because we can't re-pick Anna. So let's say we pick Betty. And there's 6 people because we can't pick either Anna or Betty because they're already picked. So let's say we pick Frank. But we did say order doesn't matter because when we think about it, picking Anna, Betty, Frank is the same as picking Betty, Frank, Anna. In fact, there's exactly 6 ways that you can pick them. But all of them are just essentially picking the same group of people. So for every one group of people, we're picking or we're counting them 6 times. Or in other words, 3 times 2 times 1 times, because that's how many ways you can rearrange this word or these 3 people. So you would have to divide the 8 times 7 times 6 by 3 times 2 times 1. And this comes up so many times that we have a notation for it. So first, let's solve the problem. You can cancel the 3 times 2 with the 6, leaving us with a 56, which is way different than what we would have got if we didn't divide by 6. And like I said, the concept of having a 8 times 7 times 6 over 3 times 2 times 1 comes up a lot, so we have a notation for it. And that's saying that's called 8 choose 3. Because we have 8 people and we're choosing 3. And the notation, you can see it like this, but a more common way of seeing it is like this. And no, this isn't a fraction because with a fraction you'll see a line through the 2 numbers, and we don't put a line through the numbers. And this essentially means this. Another way to think about it is saying that it's 3 factorial over 8 times 7 times 6, which is the first 3 numbers of 8 factorial. But wait, where did the other rest of the factorial go? Let's write that in. 5 times 4 times 3 times 2 times 1. And if we do that, we're going to also have to add it in the denominator. And let's just extend the fraction. And if you take this, then what you're going to get is that you're going to 8 factorial over 3 factorial times 5 factorial. So essentially, 8 choose 3 is equal to 8 factorial over 3 factorial times 5 factorial. Now that we understand an example of this, we can write combinations in a more general term. N choose R is equal to n factorial over n minus r factorial times r factorial. So now I really hope that you understand what combinations are. If you don't quite get it yet, we can do another example. Let's say that we have, 5 marbles. 3, those don't look like marbles, they look like pebbles, but they will do. So we want to pick 2 of these special pebbles to be in our special pebble collection. But we can pick any 2. So what we're going to do is that we have 5 like marbles, we're picking 5. So 5. Choose, you want 2 of them. 5 choose 2. 5 choose 2, right? And like we said, that's 5 times 4 over 2 times 1. And if we don't understand how I got there, then you can say that this is essentially 5 times 4 times 3 times 2 times 1 over 3 factorial times 2 factorial, but these 2 cancel out. And this is just equal to 10. So now that you understand combinations, I hope that we see in the next video to understand how they come up in the Pascal triangle. Bye!